All right, so now before we go for interesting past papers, let's go for something basic. So now let's say you're given that the position of a particle at a given time is represented by s of t, which is equals to 2t squared plus 5t. So they give you the equation which represents the position of a certain particle in a given time. So now let's say they ask you something very basic like what is the particle of that, what is the position of that particle in 10 seconds? You're just going to say s of 10 is equals to 2 into 10 squared plus 5 into 10, right? So this is going to be 200 plus 500, so it's just going to be 250, right? And let's say it's represented in meters, so you're going to say 250 meters. Now let's say they ask you the average speed from 2 to 5 seconds. So they ask you for the average speed from 2 to 5 seconds, right? So from 2 to 5 seconds, so 2 to 5 seconds. So now, what will you do? So now what you have to understand first of all is if we draw the position time graph, right? By the way, this S symbol is not new, right? It's usually represented in some physics syllabus to represent distance. So the position over time. Now notice that, I want you to notice something. Gradient is change in y over change in x, right? That's gradient. So gradient is change in y over change in x. So now notice something. Notice that here change in y will be change in position and then over change in time. Now, if we ask what is velocity, velocity is actually also equals to change in position over change in time. So in other words, the gradient of a distance time graph is a velocity time graph, right? So the gradient rather of the displacement, there's a slight difference between speed and displacement, but they're calculated the same, right? So the gradient of the displacement time graph is a velocity time graph, right? Or the gradient of a position time graph is a velocity time graph. And then I just want to show you some other thing as well. So velocity can be represented, most of us know it as this formula, right? Change in displacement. So it's the rate of change in displacement, right? So we can represent it this, or we can represent it in change in s over change in time. It's one and the same thing, right? So now I want you to understand something. Notice the definition. Velocity is rate of change of displacement, right? So if we talk about rate, we're talking about gradient, right? So now that's velocity, rate of change of displacement. Now notice something about acceleration as well. Acceleration is the rate of change in velocity. In other words, the derivative of a velocity time graph is an acceleration time graph. So we've got a pattern here, right? The derivative of a distance time graph is a velocity time graph, and the derivative of a velocity time graph is the acceleration time graph. So I'll show you where this comes in handy, right? But just know that the gradient of a distance time graph is a velocity time graph. So if they ask for the average speed, right? Remember, the derivative of distance time graph is the speed, right? So now if they ask for average speed, that's the same as them asking for average gradient, because the velocity time graph is the derivative of the displacement time graph. So if they ask for average speed or average velocity, they're asking for average gradient. So usually, even in functions, how do we get average gradient? Well, we get it the same, right? All we have to do is to first find the y values. These are going to be like your x values. So all we have to do is to find the y values. So let's find the y values first. So what you're going to do is that you're just going to say s of 2, which is equals to 2 into 2 squared plus 5 into 2. And then this is going to be 4 times 2, which is 8, plus 10, which is going to be 18, right? And then let's find s of 5 as well. So it's going to be 2 into 5 squared plus 5 into 5, right? So it's going to be plus 5 into 5. Forgive my handwriting there. So it's going to be 25 times 2, which is 50. So it's going to be 50 plus 25, which is 75. So notice that we've got the y values, right? So therefore, notice that we've got when x is 2, y is 18. So y is 18, and when x is 5, y is 75, right? So to find the average speed or average velocity is just as finding the average gradient. When they do this in rate of change and they ask for the average, nothing complicated. Also, when they ask for average gradient in any topic, nothing complicated. When they ask for the average gradient between a certain point to a certain point, all you have to do is find the y values and then use the normal gradient formula. So we know it's going to be So I'm not going to use the gradient symbol because they're asking for average speed. So I'm just going to say average speed. So average speed. Okay, let's just do this. Yeah, let me just write it, matter of fact. So average speed is equals to y2. Let's call this y2 and this y1. So it's going to be y2 minus y1 over x2 minus x1. So 75 minus 18, 75 minus 10 is 65. Then minus 8 is 57, right? So we're going to have 57 over 3. So we're just going to get the answer and run off to two decimal places. So that will be your average speed, right? So why am I showing you this? There is a difference between these two type of questions. So this is before we go to some interesting past papers, which will be at some nice levels. So if they ask you for average speed, it's average gradient. So average gradient, you just use the normal gradient formula, right? Now there is a difference between average speed or average velocity. Let me change this to velocity, right? I wanted to use velocity, but it's the same type of thing. So velocity. So let's change it to velocity. So there is a difference between average velocity and instantaneous velocity. If they ask for instantaneous velocity, they're asking for the exact velocity at a specific time, right? So here, if they ask for the velocity from 2 to 5 seconds, they're literally asking for the average. But now, if they ask for the position, I mean the velocity at a specific time, like for instance, they ask you for the velocity at 10 seconds. What are you going to do? They want the velocity at that particular point. So that's when you have to derive, right? So remember, velocity is the rate of change of displacement. So whenever we want to get the rate of something, that is actually the derivative, right? If we want to get the rate of something at a specific point in time, we are going to use the derivative. So then we're going to say the derivative of this, the derivative of the displacement time graph, which is the original formula, right? So let's get the derivative. So we're going to say the derivative is equals to 4t plus 5, right? So if you want to get the instantaneous velocity, sometimes they don't use that word, right? If they just ask for the velocity at 10 seconds, they're literally asking for the instantaneous velocity. So if they give you the position time graph, then they ask for the velocity at a particular point, immediately you have to derive, and then you can find the velocity at that particular point. So this is just going to be it, right? So then we're going to have 45. Now remember it's meters, so now speed will just be meters per second. Let's just say it's measured in seconds, right? So they will also tell you what it's measured in. So now let's go further from here. So now let's say they ask you for the acceleration at that same 10 seconds. So we've got a problem. We're given a distance time graph, but all of a sudden they ask us for acceleration. But we know something. We know that the derivative of a distance time graph is a velocity time graph. And then the velocity of the derivative of the velocity time graph is the acceleration time graph. So what does it mean? It means that when you derive once, you get the velocity time graph. But when you derive twice, you get the acceleration time graph, right? So therefore, we are going to get the second derivative of the displacement time graph, right? Because the derivative of a displacement time graph represents the velocity time graph, and the derivative of the velocity time graph represents the acceleration time graph. So then we're going to get the second derivative, which is going to be, is literally going to be 4. So we have a constant here. It means that no matter what value I put of t, the answer is 4. So therefore, it means the acceleration at 10 seconds is going to be 4, right? So it's going to be 4 meters per second squared. So there we have it. So now let's go for something interesting. So just remember that the derivative of a displacement time graph is a velocity time graph. The derivative of a velocity time graph is the acceleration time graph, right? So this will help you to know whether you must use the first derivative or second derivative. So use the derivative when they ask for the velocity at a specific point. That is like us asking for a gradient at a specific point. That's when we use derivative, right? But when we ask for the gradient between 2 points, we use the normal gradient formula.
Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEP, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement.
If you're interested in knowing the prices, the video that contains the prices and the updated contact details just in case these ones have changed is found at the end of this video. So now let's start with this particular question before we go to some very interesting questions. So now they said, just in case it's not clear, they said during an experiment, the temperature T in degrees Celsius varies with time in hours according to the formula. So they gave you the temperature in degrees Celsius and the time in hours. It's important to know the unit, right? So sometimes the time will be in seconds, sometimes it will be in hours. So now they say determine an expression for the rate. So by the way, this formula that they gave us, just in case it's not clear, this is the temperature that varies with time, right? So it's going to be 30 plus 4t, right, minus half t squared. So now they say determine an expression for the rate of change in temperature with time. So if they ask for the rate, they're asking for the first derivative, right? So by the way, remember the fact that when we're given distance, because velocity was the rate of change of the displacement, then we had to derive that equation, right? So when they ask for the rate, they're asking for the first derivative. So what we're going to do is that we're just going to derive it. So this is going to be very basic. So this disappears. This one is going to remain 4. Then we're going to have minus t, literally. So this is it. All right. So now they said during which time interval was their temperature decreasing. So you have to understand something about the first derivative. Remember, when something is increasing, the gradient is positive, right? And when something is decreasing, the gradient is negative. But the first derivative actually tells us the gradient. So therefore, if the first derivative is positive, then we know that it's increasing. But if the first derivative is negative, then we know it's decreasing. So therefore, if they ask you where is the graph increasing, all you are going to tell them is that the first derivative must be bigger than 0. That's where the graph will start increasing, right? If it was decreasing, we'd say it's less than 0. So we'll tell them the first derivative is greater than 0. Therefore, it means 4 minus t must be greater than 0. And then if we take 4 to the other side of the equation, we're going to have t must be greater than negative 4. And then every time we divide or multiply by negative, the sign of the inequality will change. So then we're going to have t must be less than 4. So it means when the time is less than 4 seconds, that's where the temperature is decreasing. Alright, great. So, yep, that is it. Nothing special. Now let's go for something interesting. Alright, here is something, right? So, they said a cyclist rode from town P and stopped at town T. So the cyclist rode from town T, rather town P, and then stops at T, right? And then they said the speed in kilometers per hour. So now we know we're dealing with kilometers and time is in hours here, right? So the speed in, by the way, they like measuring speed in kilometers per hour and velocity in meters per second. So they said the speed in kilometers per hour at which the cyclist rode is represented by the equation. So they give you the equation. Let me just write it in bold just in case it is not visible. So it's going to be the first derivative. So notice they did something here. Notice they gave you the first derivative of distance, right? So why? Because the derivative of a distance time graph is a speed time graph, right? So that's what they did. They gave you the derivative. They're telling you this is the derivative of something. It's the derivative of the distance time graph. And remember, S is usually used to represent distance in physics, right? In those other syllabus. So they said calculate the maximum, rather calculate the minimum speed that the cyclist reached on this side. So if they ask for the minimum speed, so notice they're not asking us to derive something, right? This is already the equation of speed. So if they ask us for the minimum, they're asking us for the lowest in this part, right? So there's two ways to get the minimum. Whenever they ask for the minimum or maximum, we know, first of all, that we can use the first derivatives, meaning that we'll have to derive this that is already the first derivative, meaning that we'd have to get the second derivative and make it, okay, fine. We would have to get the second derivative and make it 0, right? This is one way to get it. Another way to get it is whenever you've got a parabola, we can always get the maximum or the minimum. How do we do that? Notice, if it's a smiley face parabola, it has got the minimum, right? If it is a frowny face parabola, it has got a maximum. So we basically have to find the x and y values of the turning point. So the x value tells us where is it going to be maximum, and then the y value tells us the exact maximum or minimum value. So these are two ways, right? So let me just see something, because I see that this is minus, and then they ask us, okay, I thought that they asked us for minimum. It was going to be contradictory. So now they said calculate the maximum, right? How do I know it's maximum? Remember, this is a parabola, ax squared plus bx plus c. If a is positive, it's a smiley face. If it's negative, it's a frowny face. So if it's negative, it is a maximum, while if it's positive, it's got a minimum. So because it's negative, we expected maximum. So two ways to get it: to get the second derivative and make it 0. I mean, to get the first derivative of this, which is the second derivative, and make it 0, or to find the x value of the turning point by saying x is equal to minus b over 2a. Right? Only if it's a parabola. If it's another equation, then you have got no choice. When they ask for maximum or minimum, you have to get the first derivative and make it 0. So let's just do it both ways. So when we derive this stuff, this is going to be equals to minus 6t plus 18. And then if we solve for when it's equals to 0, we get minus 6t plus 18. So this is going to be 6t is equals to 18. Therefore, we divide both sides by t. We get by 6, I mean, t is equals to 3 here. But this is not the maximum, by the way. I'll show you something. This is the x value that gives you the maximum, or the t value that gives you the maximum, right? So this side minus x, x is equals to minus b over 2a. So here, instead of saying x, we can just say t, because now it's t. So t is going to be equals to minus 18 over 2 times negative 3. So this one is straightforward, right? So hence, understanding is better than just knowing how to do something. So this is going to be 3. All right, great. So now we got the x value. So how do we get the y value? By substituting into the original formula, right? The original formula in this case is the derivative, right? So because we have derived the derivative, so therefore when I get the original, the derivative will be the 1. So we substitute 3 into that equation. So if you substitute 3, it's going to be s prime 3. So s prime 3 is going to be equals to negative 3 into 3 squared plus 18 into 3. So 3 squared is 9 times negative 3 is negative 27. And then negative 27 plus 54, because this is going to be 54, is going to be 27. So therefore, the maximum value is 27. All right, great. The maximum speed is 27. So I'm going to show you something interesting. The next question is going to get interesting. So I saw something interesting. So now notice something. They said, okay, fine, let me keep this formula. So now they said, calculate the distance between turn P and turn T. So they want the distance between time T and time P. So the problem that we have is that we have the derivative, but they're asking for the distance, which this is the derivative of. So what do we have to do? We have to get the original equation, right? So first of all, if we can find the time P to time T, we are going to be, once we get the original equation and substitute that time, we're going to get the original distance from time P to time T, right? So what we need is to find out the time, and then when we find the original equation, we're going to substitute that time, and then it's just going to tell us the distance from P to T. So how do we get the original equation? All right, sometimes this you might feel like it's above the syllabus, but honestly, they even give you marks for it. They give you marks for the quotient rule as well, which is above the syllabus. And this is really, really nothing hard. It is as easy as the derivative. So what are we going to use? We're going to talk about integrals. What are integrals? It's the opposite of derivative. So if you want to get the integral of something, this is the rule you follow. You'll say, if we have something like this, ax to the power of n, right? This is normal. This is just like having this stuff, right? So if we have got this, how you get the integral is that you just add 1 to the exponent and then you divide the whole thing by the answer you got. Nothing difficult, like really nothing difficult. So this is the formula. So what we're going to do is, notice for the first one we have, so let's just write. So now we want s of t and not the derivative. So now what we're going to do is that you're just going to add 1 to the exponent. So 2 plus 1 is 3. So therefore you're going to have minus 3t to the power of 3. And then you're going to divide the whole thing by that answer that you got. Nothing difficult, right? So we're going to do the same thing here. So this is an invisible 1. So 1 plus 1 is 2. So we're going to have 18t squared, and then we're going to divide the whole thing by 2, right? Which is the answer that we got. So this is going to be minus t3 plus 9t squared. So that is the original equation, and we literally did not find the time. Let's find the time. Let's find the time it took from P to T, right? So how do we find the time? Notice in the scenario, they say the cyclist rode from town P to and stopped, right? And stopped at town T. So we know that when the speed rather becomes 0, right? Then it means that he's at town T. So when does it become 0? So remember, it started from 0, right? Because there's no speed at the beginning. Then it starts increasing speed, so it's going to be traveling. Then once it gets a T, he stops. So let's solve for when is it 0, so that we can find out when did it start, when did it stop. Okay, of course it started at T0, I mean, but let's find out when the speed is 0, right? So that we can find out the times. So obviously one of our answers has to be 0 because it started at t0, and then the other answer will represent when it reached t. So we're going to solve for when it's 0. So 3t squared plus 18t. So let's just remove this stuff. So let's do this. So this means that we solve it like normal algebra, right? So, but we can divide everything by 3 in the meantime, by negative 3. So if we divide everything by negative 3, we get t squared minus 6t. So now we can solve normal, right? Just like in algebra. So this means that 0 is going to be equals to, we factorize t, and then we're going to have t minus 6. So we're going to have two answers here. We're going to have t equals to 0, which is expected. The time starts from 0, right? And then the next t will represent when it stopped, which is 6. Yep. So there we have it. So this is in hours, by the way. So also wherever I didn't put the SI units, we have to, if they ask for maximum speed, kilometers per hour. So we just have to be careful. So yeah, so we have the time at which it stopped. So therefore we can take this and substitute into the original equation for distance, and then we will get the distance it took. So therefore it's going to be 6 cubed plus 9 into 6 squared. Okay, so 6 times 6 is 36. 36 times 6 is the same as 3 times 6, 180. 6 times 6, 36. So it's going to be 216. Negative 216. I'm going to verify this part just now. 6 squared is 36, then times 9. Okay, so it's the same as, let me just say something. It's the same as 360 minus 36. Yeah, so it's going to be 324. I'm going to verify this. I'm just playing around with this stuff. So 324. So let me just check it out. Alright, I did say it was 360 minus 36. I don't know why I thought it was. So yeah, okay, fine. So let's just do this. Let's just fix it. Alright, matter of fact, there's actually no mistake I made. I literally thought I made a mistake. So I was just playing around with this. So now, let me say something. 24 minus 16 is 8. So then this should be 108. Yeah, it should be 108. Alright, great. So yeah, it will indeed be 108. So there we have it, 108 distance in kilometers. So there we have it. So now let's go for something even more interesting. All right, here is another question. So they said after traveling a distance of 20 kilometers from home, a person suddenly remembers that he did not close the tap in his garden. So let's picture that this is the home and he traveled 20 kilometers. So he traveled 20 kilometers and then um, so this is what it's talking about, right? So this is home, then he traveled 20 kilometers. So now they said, and then when he's here, he remembers that he forgot to close the tap in his garden, right? So they said he decides to turn back immediately and return home to close the tap. So it means that he's going to travel 20 kilometers home in order to close the tap. So they said the cost of water at the rate at which the water is flowing out of the tap is 160 per hour. So the minute they do this, we know we're going to say 160, 160 rather per hour, right? So we know we're going to say 1,6h, right? You can even put the zero, I mean, there's no difference. So whatever amount they give you, when they say per meter, it means you multiply that number by the distance, right? But here, because they said 160 per hour, it means we're going to say 160 times the hour. So now they said the cost, so they gave us the cost at which water is flowing out of the tap, right? So now they gave us the cost of petrol as well. They said the cost of petrol is 1.2 plus x over 4,000 rands per kilometers, where x is the average speed in kilometers per hour. So here we've got the cost of petrol, and then x represents the speed, right? So now they said calculate the average speed at which the person must travel home to keep his cost as low as possible. So meaning that they want us to minimize the cost. So let's come up with the equation of the cost, right? Remember, we're given two costs. We're given the cost at which water is flowing out of the tap. We're also given the cost of petrol. So let's just create that. So whenever they give you different costs, you can just add them to get the total cost. So then this is going to be 1.2 plus x over 4,000, right? So this is the cost of petrol. So it depends on the speed, and then we also have the cost of at which water rather is running, right, out of the tap, right? So uh, that that depends on the hour, right, which is 1.6 times the hour, right, because it's 1.6 per hour. So this one depends on the speed. The cost of water depends on the speed, but the cost at which water is flowing here depends on the hour, right? So we have created the equation for the total cost, so we just add them. But we see a problem here. The problem that we have is we've got two unknowns, right? The speed and the hour. So now we need an equation that has the speed and the hour so that we can make one thing the subject of the formula so that we can immediately have only one unknown here. So which equation is that? The equation that has got speed and hour is, of course, speed is equals to distance over time. So speed is equals to distance over time, right? Now notice that we have the distance at which you'll travel, right? So we can easily relate it with the speed and the time. So then it means that the speed, which is x, is going to be equals to the distance, which is 20 kilometers, over time, which is the hours. So which one can we make the substitute of formula? We can make anything the substitute of formula, but one thing will be longer than the other, will be sort of a long cut than the other, right? So in order to get straight to the point, notice they said calculate the average speed. So meaning that we need to calculate the speed. So if you want to end up calculating for speed in simultaneous equation, we need to make the hours the subject of the formula in one of them so that when we substitute, it goes out and we'll be left with the speed only, right? But it really doesn't matter. Even if you made the hour the subject, the speed the subject of the formula, you'll end up solving for hours. Then you will have to come back and solve for speed, right? But just to keep it straightforward, if you want to end up solving for x first, you have to make h the subject of the formula so that when you substitute it, you just solve for x. So let's make h the subject of the formula. So then this is going to be, let's just cross multiply. So we're going to have hx is equals to 20, and then we divide both sides by x, and then we're going to have h is equals to 20 over x. So there we have it, right? So now we have made h the subject of the formula so that when we substitute it into the other equation, we can immediately get rid of h. So h is equals to 20 over x. So then it means it's going to be 1.2 plus x over 4,000. And then we're going to have plus 1.6. And then we're going to have 20 over x. So this is going to be 1.2 plus x over 4,000. and then we're going to have 32, right? Yeah, 32. So we're going to have 32 over x. So we need to minimize the cost. So just remember, we just added the cost. That's what we do. That's what rather we did. But the problem that we had is that this one depended on the speed, this one depended on the hour. So we needed another equation to make something the subject of the formula so that we could substitute. So now we've got the equation for cost. I hope it is clear. I hope I made it clear. Let's just write it like this so we know it's 1.2, right? And then this is plus x over 4,000, right? So x over 4,000 plus 32 over x. So now we need to minimize, but before we minimize, remember when we minimize, we just make the first derivative equals to 0. But before we get the first derivative, we need to make this into a differentiable form. So this is going to be 1.2 plus, when something's on top, it's the same as it being on the side. So we can just shift it on the side. If we shift it on the side, there will be nothing left on top, meaning there is a 1. So we have 1 over 4,000 x. And then here, this is down. We need to shift it on the side, meaning we need to move it from down to on top. So this is going to be 32, right? When we move it from down to on top, what's left here is going to be 1, but we don't need to write over 1. So when we move something from denominator to numerator, the sign of the exponent changes, right? Remember when I put it on the side, it's just like putting it on top, so it's the same thing. So now we have the full equation. So now we have written the cost in a differentiable form. So now we can easily minimize it. So let's get the derivative. Let me just do this for fun. The cost at x. So let's get the derivative. So it means the first derivative is going to be equals to, this will disappear, and then this remains 1 over 4,000. Yep, literally that's what we have. All right, great. And then this side is going to become minus 32x to the power of negative 2. And then now we have to tell them the derivative must be equals to 0. And then there is a mark for that. So then it's going to be 0 is equals to 1 over 4,000 minus 32. Okay, let me write this. When you're solving for x, it's much better to put this down, right? But when we're deriving, we have to put it up so that it can be a differentiable form. So when it's negative, it's much better to put it down. So it's going to be x squared. Yeah, so when something moves from numerator to denominator, the sign of the exponent changes. So I take this to this side, it becomes 32 over x squared is equals to 1 over 4,000. So now I cross multiply. When I multiply, that is going to be x squared, and then when I multiply this 3 times 30, right, times 4 is going to be 120, right? And then 2 times 4 is 8, so we're going to have 128. So we're going to have 128 plus these 3 zeros, 0, 0, 0. Right, great. So now we're going to square root that, and we're going to immediately get the speed. So we're going to get 357.77 kilometers per hour. So this is it. Super weird, right? It's weird because this is almost like the top speed of a Ferrari, right? So imagine having to travel that speed on a normal road. So it's kind of unrealistic. But yeah, this is the answer. But always make sense of your answers. Alright, so now looking at this question, here is another nice level. So they said a hotel has 72 rooms to let to clients. The daily rent per room is 500 rands. If the rent is increased by 100 per day, meaning that they'll be adding 100 on top of their rent, right? So it means if today it's 500, tomorrow is going to be 600, the next day is going to be 700, right? So the rent is being increased by 100 rand per day. Then they said 2 rooms can be left vacant daily, right? So the first time I actually did this question, I didn't get the answer, right? So I'm sure some people did and they did not get the answer, not because they did not have skills, because of misinterpreting the question. So my misinterpretation was that when I saw 2 rooms can be left vacant daily, I just rather focus on 2 rooms can be left vacant. So I thought it was going to be 70 afterwards. But they said 2 rooms can be left vacant daily, meaning each day they're removing 2 rooms. So some questions I solve them on the spot when I make a video. Some questions like this one, I had to check it twice. All right, so you have to make sure you don't misinterpret the question. So their prices are increased by 100 rands per day, while at the same time 2 rooms are being removed per day, right? So that is actually the question. So let's talk about okay, fine, let's deal with this part first. They said the rent is X rent per room per day, where X is greater than 500, right? So now they said show that the total daily income can be given by this amount, or rather this formula. All right, so now let's come up with the equation for the cost first, right? So we know that at the first day, right, at the exact first day, it's going to be 500, let's just say today, right? And then one day after, which is tomorrow, it has to be 600. Then 2 days after, it has to be 700, right? So it means on day 0, which is today, must be 500. But on the next day, we must increase it by 100. On the second day, we must add another 100. So basically, you're going to say 500 plus 100. And notice how this will match, because if it's one day, notice that 100 is added on top of 500. If it is 2 days after, notice that we now have 200 being added on top of 500, right? If it's 3 days after, we have 300 being added on top of 500, right? So we can get the price for a particular day that we want. Maybe we want to find out the price on the second day. Remember, on day 0, it's going to be 500, which is like today, right? Then tomorrow, it has to be 600. The next day, it has to be 700. So notice that if I put day 2 here, right? So day 2 not starting from today, right? Starting from the day it increases. No wonder they said X is the rent per room where X is greater than 500. Why greater than 500? It will start counting from when we increase. So that's what's going on here, right? Quite weird, but this doesn't always come out, this particular part, right? So X is so the rent is X rent per room where X is greater than 500, meaning that we only care about X when we are increasing, right? So we start rather counting from when we're increasing. So day 1 is the first increase, right? So that's how it is. So day 0 is like today, then day 1 is the next day, then day 2 is the day after tomorrow, right? So then it means that we're going to represent it in this formula. So I hope you understand why I put it in this form, right? So it depends on the number of days. The number of days determines how much will be added on top of 500. So this is X, right? Yeah, this is X, right? So the price depends on the particular day, right? If it is after 3 days, right? If it is after 3 days, we're going to have 3 in place of N, and then we'll get 800. So that will be the price. So the price depends on the day. So now that we got the price out of the way, let's deal with the rooms also. So we know that the income, right? Okay, let me just show you something. The income, first of all, is supposed to be equals to the number of rooms, right? So the number of rooms times the amount, right? So the number of rooms times the amount. So times the amount, which is X. This is the income. I'm sure you agree with me, right? The income is equals to the number of rooms times the rent. But the problem we have with the number of rooms is that 2 rooms are being removed daily. So how are we going to represent that? So we're going to say, first of all, we have got 72 rooms, but then 2 rooms are going to be removed daily. So now it's just the same as this formula. So now it depends on the particular day, right? So if it is maybe after 2 days, we're going to say 2 times 2, 4. So 4 rooms should be removed from the original starting point. So this is what we have. So now we have X as well, right? So X will be equals to this part, right? So then we're going to say 500 plus 100N. So that's what we have. So now we have to multiply. So I hope you get it. For instance, on the first day, the prices increased. We know that the price is supposed to be 600. So if we put 1, we're going to have 600, right? So that will be the price. And then the rooms at the same time will be 72 minus 2. So we just left the first 2 room vacant, right? The first 2 rooms vacant. So then this is going to be 70 times this stuff, which is 42000, right? So this is going to be the price for the income rather for the first day, right? So that's what's going on. That's the logic, right? So in order to get the income, it's just the price times the number of rooms. So we know the number of rooms are going to decrease by 2 every day, right? And then here, the prices are going to be increased by 100 rands every day, right? So if you want to increase or decrease something daily, you can easily use this formula. This should just be your mentality from now on. So let's distribute. Okay, before we distribute, notice something. We've got a problem. They said show that the daily income can be given by let me read it again. They said show that the total daily income I is given by this formula, right? So the problem that we have here is that we have got X, but here we don't have X. Here we've got N, right? So we have to represent it in terms of X, which is the price, not the number of days, right? So how are we going to do it? What we're going to do is that we're going to come back here and then we're going to make N the subject of the formula. So if we make N the subject of the formula, notice we're going to have X minus 500. So X minus 500, and then this is going to be equals to 100N. We divide both sides by 100. So I hope my handwriting is not too bad. So this is going to be the new price, right? So it means everywhere we see N, we have to substitute it with X minus 500 over 100. So let's do that. So then this is going to be 72 minus 2. I'm thinking of breaking this down. Let's just break it down. Instead of dividing everything by 100, we can actually divide this by 100 and this also by 100 when there's a minus, right? So whenever you've got many terms, you can actually divide each term. Just like how you would have a quadratic equation with negative. Okay, let's just do this. Let me just do this quickly. Let's just say you've got a quadratic equation with negative, right? So what you would do is that you would actually divide everything by negative. So it's actually what we're doing here. We're dividing, in order to get rid of the 100, we divide everything by the 100. So this is going to end up being X over 100 minus 5. My mind was already here. This is 5, right? So that is N. So now let's substitute. So this is going to be, so even if you write it in the original form, you should get the answer. I just do it in this form because I feel like it's going to be quicker. So this is going to be X over 100 minus 5. So that's what we have, right? So here we're going to have 500 plus 100. So we're going to have X over 100 minus 5. Okay, I hope my handwriting is not too bad. So let me just write it over here so that I can get more space. So then notice what's going to happen. This is going to be 72 minus 2 times this. 2 will cancel with 100 and leave 50 at the bottom. So we're going to have X over 50, right? So we're going to have X over 50. Then when we multiply here, we're going to have 10, right? So I just distributed. I hope you get it. I hope it's not complicated. So now let's work with that one as well. We have got 500 plus. Now notice this will cancel this when we distribute, and then when we distribute again, so for now we have X. When we distribute again, we are going to have minus 500. And boom, check what happens here. This cancels this. So yeah, so this 72 plus 10 is 82. The nice thing is that we saw 82, so we know we're moving in the right track. So this is going to be X over 50. And then this is going to be literally X. We're left with X only. So when we distribute, we are finally left with 82X minus X squared over 50. And there we have it. Now the income is given by this. So it was quite weird. So whenever they ask you something that you already know how to calculate, but you see it in another symbol, you have to get a formula where you'll make that thing the subject of the formula. So that's the pattern. I'm sure you have seen that it's a pattern, even in optimization and stuff. So now they ask for the maximum daily income. We know if we want to get the maximum, all we have to do is just to take the formula and find the first derivative. So we take the formula, and let me just do this for fun. Let me put X. So even though we can just put I. So this is going to be 82. then it's going to be, okay, fine. Is it in a differentiable form? Yes, it is, but let me make it into a differentiable form even much better. So this is 82x. Come on, let's fix this. So let me just write it one more time. So this is 82x minus. Now this I can shift it on the side. So if I shift it on the side, there's an invisible 1. So 1 over 50x squared. So then now I can derive because everything is in a differentiable form. So if you want to write this, you have to write this from the beginning and stuff. Yeah, I'm just doing it for fun. So this is going to be 82, and then we're going to have, if I multiply 2 will cancel 50, and I'm going to have 25, and then I have x. Yep, that's what I have. So we tell them that the first derivative must be equals to 0. So this is what we're going to do. We're going to say 0 is equals to 82 minus 1 over 25x. All right, great. Yeah, so I was just checking if there was any negative exponent, but there wasn't. Okay, so we take this to the other side of the equation. So now, by the way, I can actually join it back up there if I want to, right? So this is going to be 1 over 25x is equals to 82. You can divide both sides by 1 over 25, but why not just multiply both sides by the reciprocal, which is 25 over 1. And then now we're going to have x is equals to. We can use the calculator, but I just want to play around with the scale, because notice that this cancels this, and then we're left with 82 times 25, right? This we can easily get without the calculator. This is 82 is the same as 80 plus 2. You can use the calculator. I'm just doing this for fun. Then this is going to be 20 plus 5, right? So this is going to be 1600. Then it's going to be 40. Then it's going to be 40. Yep, and then it's going to be what? It's going to be 10, right? So therefore, 160 plus 400 is 2000. So now we have 2040 plus 10, 2050. Yep. So we're going to have 2050. So the calculator is not really needed.